Hey guys, so I wanted to give you an update or a follow-up on one of the previous videos from earlier this week. I mentioned I had fried one of the power modules, basically a power converter, DC to DC power converter. And anyway, you can watch that video if you want, but I wanted to give you an update on where I am because of that. So fortunately, I had purchased previously an extra two of those power modules. I can't remember for the life of me what my logic was, but nonetheless, I have a spare. So I'll show you what I did and how that's wired in and how it's going to be used. So first I'll just start with an overhead shot so you see kind of where things are. So you'll remember that here's the relay, here's the shift out, here's the Uno, obviously not the permanent position. Here's the power module, the new one, where the old one used to be, and you'll see why I'm pointing out the servo controller over here. So that's how things look from above. So zoomed in here on the power module and the servo controller. So basically the power module takes power from our incoming battery here. It sends it back out as at the same voltage here, which goes into our motor controllers. But more importantly, the power module allows us to regulate whether it's a 5-volt or some other voltage up to the incoming, in this case 12 volts. And I've got it set to the variable at 6 volts. So 6 volts is basically the lower voltage range for this board, but it also happens to be the voltage rating on the servos that we're going to be using. So basically the incoming voltage from our battery, which over there by the way, I'll talk about batteries in another video or whenever you guys ask about it, comes into the power module, and then we send it back out to, in this case, the servo controller, which is going to control our servos. So we have the first 4 primary servos already wired in. Those are these cables here and those 2 there. Let me show you what those are. So on the end of each arm here, we've got a servo mounted, and this servo at each corner will allow us to actually turn the wheels. Here are the wheels. Pretty awesome. But that's what the intention is there. They're not wired in yet, of course, but that's the controller for them. So a bit of kind of reasoning why things are the way they are. So the whole idea behind the relay is to allow me to turn on and turn off different parts of the robot, and that has everything to do with power management. Basically, you know, the ROVer, although eventually it'll be solar powered, and I do have the solar panels already, which are pretty cool. Hence the choice in the battery, which again I'll cover in another video or when you guys ask. But power is kind of our lifeblood, so the more efficient we can be with its use, the longer ROVer can go without needing to recharge. So if we're able to turn off parts that are power hungry, such as, for example, the motor controllers. So if, for example, ROVer is doing something such as, I don't know, recording video or just standing still, there's no need for the motor controllers and consequently the motors to be getting power. So if we can disconnect those parts of the ROVer, we're basically saving that juice. The other kind of big consideration that I've realized is amperage. So the batteries that I'm using are lithium, which is great for, you know, power and weight and all that. But you know, I do have to watch the amperage meter. So at 12 volts, each battery, and there are 2 batteries, at least for now, put out a maximum of 4 amps. So the motors have a stall rating at 12 volts that's pretty close to that. Of course, I don't plan on running them at full speed or anything like that, so that shouldn't be an issue. But if you start flipping stuff on all at once, you can pretty quickly get up there. So the other advantage of using a relay is allowing us to basically turn different things on in sequence rather than all at once. So, for example, there are 4 motors, 2 of each are controlled by a separate motor controller. So rather than switching on both of the motor controllers and all 4 motors at once, we can direct power to each motor controller, a few seconds apart before we start moving, in which case we don't have that amperage spike all at once. So that's the theory.